Good morning guys, my name is Nash Varade. Today I am explaining about classification of solids in engineering physics. This is my topic, classification of solids. Topics: classification of solids, conductors, semiconductors, insulators, band theory, electrical conductivity, application and conclusion. We discussed all about this. Classification of solids into semiconductors and insulators. Introduction to solid state classification. Solids are categorized into conductors, semiconductors, and insulators based on their electrical conductivity. The classification is determined by the band structure of the material and the movement of the electrons. Understanding these categories is crucial for various electronic applications. Next, conductors. First, conductors. Conductors have a high density of free electrons that can move easily in response to electrical field. Metals are excellent conductors due to their delocalized electrons. We all know that metals are very high conductivity. Example, copper, zinc. Copper and aluminum are the commonly used conductors in electrical wiring. These we know all of. Semiconductors. Semiconductors having a band gap between conductors and insulators, allowing for a moderate electronic movement. Silicon and germanium are the common semiconductors material used in electrical devices. Silicon and germanium are the more important. The conductivity of semiconductor can be altered by with impurities. Insulators. Insulators have very few free electrons and high energy band gaps, making it difficult for electrons to move. Materials like glass, rubber, plastic are good insulators. Insulators are used to prevent the flow of electricity for insulation purpose. Band theory. What is band theory? Now we discuss about first valency band. The valency band refers to the energy level in an atom that contains the outermost electrons. It is the highest energy band filled with the electrons at the absolute zero temperature. Next, conduction band. The conduction band is situated above the valence band. It contains energy levels that are vacant under the normal conditions like room temperature. When an external energy source such as heat or an electrical energy applied to the material, electrons can be break free from their normal state. These are the band structures. This for insulator and this is for semiconductor, this for conduction. We can see that there is no gap between conduction band and valency band. These are conductors. The small gap is present between the valence band and conduction band. This is semiconductor. There is a large gap is present between conduction band and valency band. So it is insulator. Due to this gap, electrons are not jump from valency band to conduction band. This is the theory about these diagrams. Next, electrical conductivity. Electrical conductivity is a measure of material's ability to conduct electricity. Based on the band gap, the conductivity of the materials varies. Conductors have high conductivity while insulators have low conductivity. Semiconductors have intermediate conductivity that can be controlled. Applications of conductors. Electrical wiring. First, electrical wiring. This is the major application for conductors. Conductors such as copper, aluminum are extensively used in the electrical wiring for building, homes and industrial facilities. These conductors provide low resistance pathways for electricity to flow, enable the distribution of power to appliances, light and other electrical devices. Electronics next. Conductors are integral components in the electrical circuit. They are used in the interconnects, trace on circuit boards, and within the components like resistors and capacitors. Copper is commonly used due to its excellent conductivity and availability, power transmission and exploring, etc. These are the major applications for conductors. Next, applications of semiconductors. Germanium and silicon are the most used semiconductors. Semiconductors are the foundation of modern electronics used in transistor, diodes, and the integrated circuit. The controllable conductivity semiconductors enable the development of electronic devices. Silicon-based semiconductors dominate the electronic industry. Applications of insulators. Insulators are crucial for electrical safety, preventing electrical shocks and the short circuited. They are used in cables, electrical appliances, and building materials. Insulators provide thermal and electrical insulation in various applications. These are the some diagrams about insulators: rubber, glass, oil, diamond, wood, and all. Conclusion. Now we conclude the classification of solids into conductors, semiconductors, and insulators is essential for understanding their electrical properties. Each category plays a unique role in electrical applications and technology. Further, research and development in material science to enhance the performance of conductors, semiconductors, and insulators. So, guys, this is about the classification of solids in engineering physics. Thank you.